Hello everyone, welcome to Clash Encoder. So in this video, we will see the popular question that is container with the most water. So it has been asked in various big tech giants like Facebook, Amazon, etc. So it is a medium level question on the LeetCode platform, and it is also one of the most liked question in the LeetCode. So let's read the problem statement. So it states that given n non-negative integers a1 to an, where each represents a point at coordinate I comma ai, so that means I is the x value, that is index of that, means the that is the x coordinate, and a of I is the value, that means it is the y coordinate. You can see if I is 0, so it is here, and the value of I is 1, so a of I is 1, so it will be like this. So here you can see n vertical lines are drawn, so you can see vertical lines are drawn such that two endpoints of the line I is at I, you can see I, and the second one is at a of I and a of I. So that's how it works, and I and a of I, and also this one, that is I comma 0, which is at this point. So we have to find two lines which together with the x-axis forms a container such that container contains the most water. So actually you can see for this question also we have to find the container with the largest capacity to store the water. So these are two bars, and you can imagine this as a container, and this is the blue is the water filled inside the container. So we have to find the maximum area, you can say. It is similar to trapping maximum area between the rectangle. It is similar to that. So this is how we have to find the area or maximum, the container with the maximum capacity to store water. And it is written that you cannot slant the container, and n is at least 2. That means we have to not worry about the if we get n is equal to 1. So n is at least 2, so you will get two containers simply. So let's see how we can approach this question. So the first approach that comes to your mind when interview will ask you this question is the brute force approach. So you can see I've written the let me explain you. So I've written the values of these. So actually this 8 is this value, that is x y coordinate. So these are y coordinates, that means their height, and you can see these are their heights and these are their indices, or you can say their x coordinates or the width. We can using this we will calculate the width. For example, if you want to if we are on like this, we have to calculate the, let me show you, we have to calculate the width of this box. So you can see its index is 1 and this ending index is 4. So you can simply write 4 minus 1 will be 3. So you can see its width will be 3. You can see 1, 2 and 3. So this is how we can simply find its width. So now let's find out how we can solve this question. So for the brute force way, you can simply do one thing, that is you can for the brute force, you know that you have to use two loops. So we will use two loops, that is I will iterate from this point, that is here I will iterate from here, and j will iterate from I plus 1 at every point. So as it is a brute force approach, so we will check all the possible combinations. So just let me show you. So you can see I have written the pseudocode. I will iterate from 0 to n minus 1. That means I will start from here and j will start from I plus 1. For every I, j will traverse the remaining array or remaining coordinates, and j will also run in n minus 1. And we will, for every coordinate, we will find the minimum height of both. If I is minimum, so I will also explain you one thing, that if you have this for example this container, you can see this container, so the maximum water that can be stored inside this container will be the minimum height, because if you see here the value is 7 and here the value is 3. So if you see if we try to store the water, so the maximum water that can be stored will be 3 only, because if we increase the capacity to water capacity to 4, so it will spill out of this container, because the maximum height of the one bar is 3. So this 7 bar won't do anything or won't help us. So we have to find the minimum height of both. So you can see I will run from here, and for example j is here, so we will find the minimum height. So minimum height is 1. So for example 1, so that means we can store only one water up till height 1 only, because this 8 will be wasted. 7 out of 8 will be wasted, because only we have the one bar which is only of size 1. So that's why we are taking the minimum height. Then for calculating the area, we have to simply multiply the height, that is length, by the breadth. And we saw that how we can calculate the width, which we calculate simply by j minus I. I showed you before. If you didn't understand, you can simply go back and simply watch that part again. So you can simply find by 1 minus 0. So you can see 1 into 1 will be 1. So this container can store only water of capacity 1. That means, so our result will be updated. Initially our result is 0, so we will simply update our result. So then we can for every I and j, it will run, and this will automatically find the maximum maximum capacity of the water. So this solution will take O of n square time and O of 1 space. You see, because approximately O of n square, because you can see I and j are two loops, nested loops, so it will take that much time. So now we can like think of the better approach. Interview will ask you to optimize the solution further, so you can simply think of the two-pointer approach, because here you have to only find the maximum, like the value that we can store what of the water. So that's why we can simply use two-pointer approach, as you would have seen in the like trapping rainwater problem. So you can simply get the idea from like these problems if you have solved them. So this is like bit much simpler than that. So you can simply, in this solution, we have to, first of all, you can see I've initialized the result as 0 and a left and right value. So as we are using the pointers, so left will be initialized to this point, left will be at this point, that is a 0 index, and right will be at n-1, which is this index 8. Length will be 9, so it will be stored at 9 minus 1, that is 8. So now you can simply see we are simply just like writing the condition, that is if left is less than right, we will simply like check the height is equal to minimum of both. So if left and right, for this for example, this left is at this point, so you can see left it as this point at this point, and right is at here. So we will find the minimum height of both. So minimum will be 1. So you can see out of 1 and 7, minimum is 1, and we will be able to store only water at height 1 only. 7 won't matter. So that's why we are calculating the minimum value, and then we are finding the like width. Width is r minus l, so it will be 8 minus 0, that is 8. So it is of width 8, and its area will be height into 8. Height is 1 and width is 8, so area will be 8. So we will simply update the result value. So now we will simply update the result value, and like if now for iterating next, let's like see the code and try run it. So actually I will like run. So you can see left is first left is here. So if our left is here and right is here, you can simply see we will find the minimum height. Minimum height will be 1, and as I told you, the height will become 8. So like height is 1 and the current area will become 8, and our result will also become 8, as left is here and right is here. And then we will check if the height of left is less than right. So yes, left is less than right, so we will increment left, because if we increment left, maybe we will find a height greater than the previous left height. So that's why we are incrementing it. And in this example, we are lucky enough to find the like next index only. We have find that we are having the value with the like left value greater than the previous left value. So you can see it is 8 now. So the minimum of both is 7. So you can simply the height will be the minimum of both, so it will be 7, and current area will be our 7, and the index of both is right is at this. So 8 minus 1 will be 7. So if you multiply them both, so it will become 49. So 49, our result, previous result was 8. This is our previous result, and we will update it to maximum of previous and the current. So current is 49. So we are simply getting the like greater area, you can say, or the capacity. So that's why we are incrementing it, or like updating it. So now left will, again we will check for this condition, if height of left is less than height of right. So no, this time left is greater than the right, so we will increment the or decrement the right pointer, and it will come to this point. So we are finding to the like if we are getting more height than the previous point. So that's why, sorry for the like this representation, sorry for that. And now you can see our right is here, so right is 3. So minimum of them is 3, and 8 is 3. So minimum is 3, so height will be 3, and then current area will be 3 into this index is 7. 7 minus 1 will be 6. So 3 into 6 will be a smaller value than the previous value, but we know that. But still, the algorithm will run for all the like bars, and it will check and find the maximum area. So it will be 18. So previous result is greater than the like this current area. So that's why 49 will stay as it is. Now we will simply we will check again if right is smaller than left. So yes, it is again smaller. So we will increment our right pointer. So right decrement our right pointer, because we are like running from n-1 to like 1 or 0. So this is where right will come. Now you can see, I will simply erase this because it will be confusing for you also. So now you can see our right pointer is at this point. So our height will be minimum of both is 8 only. So maybe we can get a higher value, or the higher area than the previous, but let's see. So 8. So now you can see the current area will be the height, that is 8, and the index of the like this will be the width of this will be r is 6 and l is 1. So 6 minus 5 will be 6 minus 1 will be 5. So you can see the area is 40, but it is not greater than the previous result. So it will stay as it is. The result will stay as it is. So it will run against all the values, and now you can see our left will be incremented now they are both similar, so we will simply decrement the r, because if we are similar then we will get into this part, that is else part. So actually I'm getting the problem in seeing the cursor actually. So this is the right part, so we'll simply decrement the right pointer. If we get to this point, so it will come here, so at the 5. Now we will again check, but we won't be able to find any greater value. So this was how the 2-pointer approach works, and it will only take O of n time, because we are only traversing the array. So you can see L is incrementing and R is decrementing till L is less than R, and the space will be O of n, because we are only using 3 variables that are, or you can do it in one condition also, but I'm actually like I have wrote it to like simply make it understand easier, so easily. So you saw, I hope you understood this, and let's see the code on the LeetCode platform. So I've written the code in C++ and Python, and I will share the code in the description in the GitHub link. So if you want the code, you can simply refer to that link. So you can see I have initialized the result variable, and the left and the right pointer. Right will be n-1 or size of this array -1. Then we will simply check if left is less than right. Then we will update our result. We will find the result, that is current result, you can say. So the result will be max of the previous result. And sorry, this is not the current, this is the final result that we have to return. We will check if it is max of the previous result, or we will check this is our the new area or current area that we were like finding in the current variable. So we will check minimum of both height. So the minimum of both height multiplied with width, that is r minus l, that is left right index minus the left index. So that will be our new area, and that will be the previous area. So it will update to the maximum of the both. So now if the left height is less than right, then simply increment the left. Otherwise, if they are equal, or right is left, then right is left less than left value, then we'll simply decrement the right. So let's submit the solution and see if it works. So yeah, it worked. So let's find the C++ solution, Python solution, and you can see it's simple, because as I've shown you in the algorithm, so it is similar to that. So we are simply initializing our result and the left and right values. So then we are writing a condition that if left is less than, while left is less than right, then we'll simply, like this is similar to C++, you can understand that, and you can understand that. So let's submit this also. So I hope you find this video helpful. So actually if you submit again, the time changes. So actually let's submit the C++ one again also, because it was showing less time than before, or like greater time. You can see it ran faster than 93.62% of solutions. So this was how we can solve the question that was container with the most water in O of n time and O of 1 space, and this is how you have to approach the question in the interview. So I hope you like this video, and do share and subscribe to the channel, and thanks for